Welcome back to part 6 of our series where we are building a Python trading robot for the TD Ameritrade API. So, previous video, we started talking about the indicator client. The idea behind this client is it's doing all the calculation, right? So that's really the goal behind it, is it's going to be calculating all the indicators for us. It's also a mechanism of defining signals and the conditions that have to be met to warrant a signal. So that's really important. And then additionally, there's going to be a little bit of hidden magic behind the scenes where we will be storing indicator values that you pass through when you calculate your indicators to then use that later when you add new rows and update those values, right? Because the idea is that this is going to be running throughout the market. We want to be able to update those indicators as new data is added. So right now we have very limited functionality, but at least we have some type of client. So what we're going to do next is we're going to start calculating indicators. The first indicator that we are going to calculate will be called change in price. The change in price indicator is very important for the RSI calculation. These indicators always return the same things. It will always be a pandas data frame, and they're going to look very similar. So ideally, when you start looking at this, you're going to go, wow, this seems very repetitive. That's the goal. We want to make it as consistent as possible. All we really want to do at the end of the day is maybe tweak one or two things, but ideally make it relatively consistent. Now, here's where things start getting very important. We are going to define a variable. It will be called locals data. We will then use the locals function. This is a very important function, and it's very important for this whole entire process. So you want to know what's going on. Basically with the locals, I guess, function, I don't know exactly what the term is behind it. What it's going to do is it's going to show me every argument that was passed through in this function. So say, for example, I had locals up here in my price data frame property. If I printed this out, guess what would happen? Well, I'd see a dictionary basically, and then the first argument in that dictionary would be self, so that would be the name of the argument, and then I would see a value associated with that self key. That value is the data frame object, or basically this object itself, so the indicator object. I'd then see another key called price data frame. And with that one, I would see, again, a key called price data frame, and I'd see a data frame object that ideally is associated with it. Now, it's not going to be something like this. You'd actually see like a data frame. And that's important because this is a way where I can grab something as you pass it through. So if you said, hey, I'm going to calculate my RSI doing a 15-day average or 15-period calculation, I can capture that when it sends through. What you need to know about the locals is it changes depending where you call it in your function. So if I call it in the beginning, I only have the arguments that I pass through. However, say in this example right here, what if I had this here? Does it change anything that I put it after this line? It does, because now I'm going to have another argument here called self._frame. So placing this is very important because as you place it, you're going to have more arguments. So that can be a good or a bad. For me, it was kind of a bad. What I wanted is I only wanted the locals after you had called the function itself and passed through some arguments. So what I do is you're going to see the same pattern. I'm going to delete the locals data, but I'm only going to delete a specific key. It's the self keyword, because I don't care about that. I only care about the arguments that you pass through besides self. And then from here, you're going to see something, again, very repetitive. The first one is going to be column name. So that's the name of the column that I'm planning to use in the data frame. So I'll have change in price. And then I'm going to have my current indicators. So these are indicators that the user has assigned to their stock frame. So when they call that function behind the scenes, I'm storing that information. So I'm going to say, hey, add a new indicator to our current indicators dictionary. And the name of that indicator is really just going to be change in price. And then for each indicator, we're going to add a couple more pieces. The first one will be the arguments. So these are any arguments that were passed through. Some cases, it's going to be none. So in this situation, we're not going to see anything. At least I'm pretty sure we're not going to see anything. So that's important. So it's okay if it's none. You don't have to give, there doesn't necessarily have to be anything, but I'm trying to be repetitive, right? I'm trying to be consistent and make sure it's consistent. Now, the next one is going to be the actual function itself. So we're going to call this one func. And then this one is going to be the self change in price. So that's kind of nice too. I'm calling that function from within the function again. I'm storing it. I'm storing it so that way I can call it again later. And then what I'm going to do is when I call it again, I'm going to pass through all the arguments that you gave me previously. And then after that, I start calculating the actual indicator itself. So in this case, I take my frame object and I add a new column to it. That new column is the column name. And then I start taking my price groups and I grab the value that I'm going to calculate it off of. So in this case, for change of price, I'm going to use the closing price. And then I'm going to call that transform function. So this will transform or basically transform my data frame. And for each of my groups, they'll now have a change in price. Now to calculate the change in price is pretty straightforward. We're going to use lambda x, and then we're going to do x diff. And that's it. So this will calculate the change in price, which is basically just the change between the current row and the previous row. That's why you see x diff. So this one's pretty simple. That's why I wanted to start out with this one. And then really, you're going to just see this pattern repeat a few different times. However, for some indicators, it's a little bit more complicated. It's not just calling an existing function. In this case, like the RSI, there's a couple arguments that I need from you. One is you have to tell me the period. So what is the period length that you're planning to calculate on? So indicators are usually customizable. There's nothing stopping you from, not using the default. You could have a 30 period RSI. You could have 14 period RSI. So it's really up to you. And then next, we're going to have a method. This is also very common. You will have certain indicators that can be calculated in different ways. So for the RSI, there's Wilders. Then there's, there's like a smooth Wilders version and stuff like that. So I have to sometimes build in that functionality, so you might not have it right off the bat, but the intent behind it is ideally as this library evolves, I'm going to give you a little bit more customizability and say, hey, that indicator is an indicator, correct, but there's also many ways to calculate that indicator. So here is the same thing. We're going to do the RSI one. And really what we're going to do, just to kind of make our lives easier and kind of show you the benefit of following this pattern, all we have to do here is change a few things. So now it's going to be the RSI, and now it's going to be the RSI here. So kind of nice because, again, this is saving everything for us, and we're able to follow the same logic within the same function. So it's very, very useful. Now, to calculate the RSI, we do have to have the change in price. So in this particular instance, I actually have to check to see if you already have the change in price in the data frame. If you don't, then I have to calculate it for you. So I'm going to say, okay, change in price. So if change in price not in self.frame.columns, then that's an issue. So what I'm going to do is I'm going to say, okay, calculate the change in price for them. Because I need that indicator. I need that indicator in order to calculate the RSI. If you don't give it to me, I can't calculate the RSI for you. And then we're going to start calculating different parts of it. So this is probably a blast from the past regarding the random forest one. We're going to define the updates. And so with this one, it's going to be self_frame. And then this is going to be your up day. And then from here, self, we're going to have our price groups. Woo! And then we're going to say, hey, let's take that change in price and let's do a couple operations on it. So we're going to say transform. And then from here, we're going to say lambda, and then it's going to be X, and then it's going to be NP, and then it's going to be where X is greater than or equal to 0, and then it's going to be X and then 0. So this hopefully is not too complicated when you look at it, but the idea behind it is, why is it giving me IntelliSense errors? I don't like when it does that. Lambda. Price groups, okay. Is it something up here? This is where things always get fun, because now I have to see potentially where I screwed it up. If changing. Okay. Let's see if maybe this works. Fascinating. Is it because I don't have... Oh, I see. Oh, God, it's stupid little things like that. So I had an extra colon there. I swear to God that I get this all the time, and it's like, it's so frustrating. All right, so logic here, if X is greater than or equal to 0, return X, otherwise return 0. So this will only keep the values that are positive. So this will represent our up days. Now, luckily for us, the logic is almost identical for the down days, but guess what? All we are going to do now is we're going to say, hey, if it's less than or equal to 0, or sorry, less than 0, then do that. And then in this case, we actually don't want the negative value, we want the absolute value. So that's important too, is you want to make sure we have that. And then we're going to just keep going because it's pretty straightforward, I think, kind of once you start seeing the pattern here. So now we're going to have EWMA up. So this is the exponential weighted moving average for the up days. In this case, I'm now going to use my up day column that I've calculated previously, and I'm just going to change my lambda a little bit. So now I'm going to say, hey, take my X, do the EWM, so the exponential weighted moving average. And now I need to define my period, my span. In this case, my span will be the period that was passed through by the user when they called this function. So if they pass through 14, guess what? This is going to be 14 then. And then from here, what we're going to say is, hey, we are going to use the mean. So we're going to take the average of for this period, right? So this is almost kind of like it's like a rolling average, if you want to think of it like that. So that's your up. And then from here, guess what? It's, again, almost identical when you start moving to the down. So now we're just literally changing this from down. So again, very hopefully straightforward what's going on here. And then we're going to calculate the relative strength. So now we need to calculate the relative strength. Okay, so we're going to take the self frame. We're going to take the EWMA up. And then we're going to be taking the self dot frame, EWMA down. And then from here, okay, we got our relative strength. Let's do our relative strength index. Okay, so that's not too bad. It's going to be 100 minus, and then it's going to be parentheses, 100 divided by 1.0 plus the relative strength. And then that's our RSI. And then we got to do one final thing. Well, two final things. The next one is we're going to actually assign that RSI column to our data frame. And then we're going to add a condition, because there can be situations where we will actually get an infinity value. And so what we're going to do is we're going to say, hey, if the relative strength index equals 0, then be 100. And then otherwise do 100 minus. So basically, we're just going to say, take this little guy up here. In fact, I probably could just pass through relative strength index again, but I'll just leave it like this for right now. There might be an error in this. Because in my notes, I have, this is relative strength index. So I'm gonna have to check that one. I'm gonna leave that right like that for right now, because it shouldn't be index. Good thing I write these videos, right? Okay, and then add the RSI indicator to the data frame. All right, perfect. Let's move on to the next one. So normally in previous videos, I keep every column. Right now, I'm trying to make it a little bit more condensed, so I clean up before sending back. So I say self underscore frame. I'm gonna do drop, and then we're gonna have our labels. That's gonna equal EWMA up, EWMA down, and then what is it? The down day, and then the up day. And then we should be good. Oh yeah, and then change in price too. I guess technically you could leave that in there, but for right now, we'll just delete it. Okay, so we have that, and then we're gonna have our axis is equal to 1, so we're saying delete that column, and then this is an in-place operation, so delete it, we don't have to reassign it to a variable. Okay, and then from here, guess what? We can return that self underscore frame, and there we go. Everything's nice and easy. We now have an RSI indicator. Let's move on to the next one. The next one will be called SMA. This is going to be your super simple moving average. This will take a period argument as well. This will be the period in which you want to calculate the simple moving average. This is, again, going to follow almost identical to what we were seeing up here. If anything, it's actually simpler. It's actually much simpler than calculating the RSI, just because we don't have to do as much. All right. And then from here, we're going to just change a couple of things. This will now be the SMA. And then this will be the SMA. Woo. Okay. And then from here, we will be doing, we're going to be adding the SMA. It's going to be self underscore frame. And then it's going to be the column name. And then it's going to be self underscore price groups. We want the closing price. And then we're going to do a transform operation just like up above. Let's not make the same mistake I did again. And then put an extra colon there. And then we're going to do a window. And this window will be the period that is passed through. And again, with the simple moving average, it's very straightforward. It's just a regular average, so no kind of weighting or smoothing or anything like that. So very useful. And then again, we will also return back that frame. We want to make our lives easier. And then that's the SMA. Now we're going to go on to the EMA. And then this is going to be your period. This will be your int. And then this one actually has a second one. So alpha will be a float. And then this will default to 0. So I actually have a little bit more work to do with this one. I have to make it where obviously if you pass through alpha, it's going to calculate using that alpha. Right now it's not doing that, but the goal is that it would calculate using the alpha you pass through. And then again, this is almost identical to what we did up above. We're literally just changing a few things here and there. So we got your EMA, you got your EMA, and then from here, with this one, it's all we're really doing is we are just changing this to our EWM, and then this is going to be span. So now you have an exponential weighted moving average. Normally, there is an extra argument that you can pass in here. There's an alpha. So the goal is to, if you don't pass that through, I'll use the default. Otherwise, I will use what is allowed here. And then that ideally make a little bit more easier. And then we're going to go on to a really fun function. So this is actually a really important one. So if you take anything away from this video, take away this next function, because my mind was blown when I was like, oh my God, this is how you make your life easier. Okay, so we're going to define a function, and it's going to be called refresh. So I've said it multiple times throughout multiple videos. We will be adding data to our data frame as we're using it, right? Well, there's a challenge with that because these columns don't automatically update as you add new data. There is no like refresh process. It just adds the new data and then you'll have a non-value for that row. So I have to recalculate it as you add rows. And so I created this little method that basically leverages what I was capturing up here. And I basically call everything again that you used before. And it actually was very fast. I was quite surprised. I thought it was going to be really slow and it wasn't. So that was really nice. So what we're going to do is we are going to update the groups first. So first update the groups. This is just a little bit of a testing for right now. Again, I might remove this step if I can validate that it doesn't really impact anything. So I'm going to first do the price groups. I'm going to say, okay, the price groups is just the stock frame that initially was sent through. And then I'm going to call that symbol groups again. So that was also a step where why was I asking for the stock frame? I wasn't really using it anywhere. This is where I was using it. And so again, if I can kind of validate that this really isn't necessary, I will probably be removing this step and you might actually see an attribute getting removed. But for right now, I'm going to keep it in. So after that, I'm going to loop through all the stored indicators. So we're going to say for indicator in self.current indicators, what are we going to do? Well, first is going to be your indicator arguments. That's going to equal, what is it? It's going to be your self.current indicators. We want the indicator that we are on in the loop, and then we want our arguments. So that's our arguments that were passed through. And then we're going to have our indicator function. This one is going to be, again, almost identical. It's the indicator that we are on in the loop, and then we want that function that we assigned up here. So again, very hopefully straightforward. And then we're going to do a little bit of magic, because magic is always fun. Yes. So we are going to update the columns. And it's I was kind of surprised how simple this was. We're going to call that indicator function that we grabbed from our dictionary. And then I'm going to do an unpack. So I'm going to do a double asterisk. And then I'm going to do indicator arguments. And so the double asterisk will take a dictionary and basically unpack it. And so this is a nice little trick that makes it where you're calling the function and then you're passing through all the named arguments and default values that you used during the thing. And so I'll actually show you if I can indicator, what is it? What am I thinking? Python dictionary unpack. So really nice, actually. I think this is a neat little trick, and if you can leverage it, it's pretty straightforward once you kind of see it. So the idea here is that you can define a dictionary, and I'll kind of zoom in, is you can define a dictionary. You can pass through that dictionary to a function. So in here I have an add function, and that add function takes two arguments, A and B. And what it will do is it will unpack each one of these keys and then assign that with the argument. And then the value will also be assigned to that key. So that's why when you call this and then you call that unpack operation, you get 5. Very useful. Very, 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 very useful. Okay, and then we'll talk about Python locals a little bit, just because I think that is a little bit confusing, just to make our lives harder. And then, so this is one of the built-in functions. So that's me being more explicit. And then here's locals. So update and return a dictionary representing the current local symbol table. Free variables are returned by locals when it is called in function blocks, but not in class blocks. Note that at the module level, locals and globals are the same dictionary. So that's formal. I'd really like a visual representation because I think it just makes a little bit more sense. Geek for geeks, they usually do a good job of explaining stuff. Okay, so here's a good one. So he's calling in local up here, and again, keep in mind, there were no arguments passed through. There's been no operation. So what he's saying is there's no locals, right? So here you go. There's no locals. But then let's take a look at function 2. He defines a variable called name, and then he assigns, I'm assuming, his name to it. And then from here, he then calls that locals built-in function. And then notice that we now have a dictionary where it's the name of the variable, which in this case is called name, and the value that was assigned to that variable, in this case, his name. And so he can now treat this as a function where he can, it's like a dictionary where he can call it. And then the interesting thing here, though, is he's trying to say, hey, you can't change those locals after they've been assigned. So you can't change them. They're already the same. So pretty interesting, very useful. And that actually was really crucial when when I was kind of trying to figure out this mess, because if I didn't have that, my life would have been a nightmare. I mean, it could have been done, but I think it would have been a little bit too messy and I wouldn't have liked it. So we'll have to see. We're going to talk about a final method. It's going to be called check signals. And we're going to call this self. This one is going to return the union. So it's either going to be one or the other. It's going to be the pandas data frame, or it's going to be none. None. And then from here, we're going to say signals df equals self dot StockFrame. And then we're going to have the check signals. And then with this one, it's going to be the indicators. And then I'm going to pass through that self indicator signals. So we're going to have I don't know if we defined it in this other one. That was a little bit of a while ago. Yeah, so we never defined it, but it's going to be leveraging this method in our StockFrame. And just, again, as a little bit of a refresh, the idea behind here is you're going to pass through all those indicators that you gave me, right? So those signals. So you're going to say, hey, I want to check the RSI. I want to check the SMA. I want to check the EMA. And you gave me all your operations. And I'm going to compare that with the values in your StockFrame, at least the latest values. And so this is where I'm basically calling this, but I'm really passing it back through to our StockFrame. So this ideally will return some signals. And then so this will return signals df, if there are any. In some cases, you won't have any signals, depending on how strict your rules are and depending on how many thresholds that you have. So very useful. But in essence, that's really where the indicator client stands right now. So for the most part, it's really doing the calculation. It's doing that refreshing process, and it's basically passing information on to other objects. So we'll see, because we're going to have to kind of go back to it in a little bit. We will have to kind of walk through the StockFrame. However, in our next video, we are going to be covering the trade object. And so the trade object is really our mechanism for building orders and then placing those orders. So that will be important as well. So if you have any questions, by all means, ask away. Any points of confusions, again, feel free to put them down in the comments. What else? I think that's it for this one. But yeah, next video, trades. So yeah, we'll see you in video number 7.